Okay, hello. I'm sorry that I cannot be at the meeting, but Kevin is kind enough to make a videotape of it, so at least you can see what I'm doing. Okay, here is this Kevin's board, and I'm returning to him, and hope that he can run the demos in the meeting. Okay. We are rolling. Okay. Okay, here is the 430 eForth demo for the LaunchPad. I'm sorry that I cannot be at the meeting, so Kevin is kind enough to make a videotape of it. So what I'll be talking about it will be a little bit about the LaunchPad and its latest version. And I will show you some Code Composer Studio IDE. And originally this project was the 430 eForth for the G2231, which has only 2K flash memory. Now we have the 430 eForth for the G2553, and that has 16 kilobytes of flash, and it's much more interesting. Okay, I'll show you how to do turnkey applications in the end. Okay, this is the standard picture of the LaunchPad. I think everybody knows that. But the originally the 2231 is a 14-pin DIP package. It's a small package, and then the 2553 is a 20-pin package, and which occupies the entire DIP socket. So that's a much more interesting microprocessor. Okay, now this is the old LaunchPad, which has the 2231 microcontroller, 2K bytes of flash, 256 bytes of RAM, and a whole bunch of other things. So it is interesting in that it's you can build some small applications around it, but it's not interesting because you cannot fit forth in the 2K bytes of flash. So now we have the LaunchPad 1.3, which is delivered with MSP 430 G2553 microcontroller, and it does have 16 kilobytes of flash memory. And the 256 bytes of information flash, that's kind of interesting. I'll talk about it later. And the RAM space is expanded to 512 bytes, not enough, but adequate. And the chip is running on an internal oscillator, which runs at 1.1 megahertz. You don't need an external oscillator. So in the 430 eForth, I was using IAR IDE, which basically is a nice assembler. But now IAR system, the free version is limits you to a 4 kilobyte footprint, and that's not enough for the eForth. So I switch over to Code Composer Studio 5.2, and the free version allows you 16 kilobytes of your code. So that's I think good. That's good enough, but it's much more complicated because basically it is designed to compile C or C++ code, but I'm only using the 430 assembler. In this this environment is very nice. It comes with the USB programmer, which also serves as a UART terminal. And it has a very nice target debugger. and I can do a little bit of demo of that system. So it is a much more powerful environment, but need lots of attention to the details. So 430 microForth, that's what I did last year with the G2231. And because we only got 2 kilobytes of flash, so I have to throw away lots of things, including the compiler. So this implementation was an interpreter-only version. And the eForth model is greatly reduced to fit into the flash memory. It has a software UART, which I adopted and carry over to 430 eForth. Okay, so the eForth, I actually took the original eForth on 8086 version 1.0, so that's the classic eForth. And I took that version and converted it to be assembled under the CCS 5.2. So I have most of the kernel words implemented for the 430 microForth. So that's being ported over. So the kernel is almost already done. But based on the original eForth 86 model, I threw away all the multitasking elements. And I also threw away the catch throw. And I was thinking of doing some serious optimization, but I don't really have enough time to go over all the code to try to optimize all the commands. So this is interesting in that new words are compiled directly to Flash. And so you can go along and just add more code to the system quite naturally. The initial values of user variables are stored in the information flash, segment E. And this is nice because the segments, each segment has only 64 bytes. And in the main flash memory, each segment is 512 bytes. So you have 4 information segments to store some small amount of information there that you can help you boot up the system. So the minimum support for turnkey system, you can actually do turnkey system on this platform. At 1.1 megahertz, 100,000 empty loops per second. So that's not too bad. The CPU is a 16-bit CPU, so it is much nicer than any of the 8-bit microcontrollers. So the MSP 430 is a 16-bit microcontroller, and so it's much more compatible to Forth than the 8-bit AVR microcontrollers. 16 registers are more than enough. I used only about 6 for the Forth to run. And the Code Composer Studio, it is very smooth, though very complicated. And the USB interface is especially nice because you don't have to worry about it at all. It all runs at in the background, and I don't have any trouble in connecting the USB cable to the system. Okay, so here, this is how you would do the turnkey system. Because the flash memory, you can basically write to the flash memory directly. But it's kind of hard to erase the dictionary. because you have to erase in 512 byte pages. And it is very difficult to code forth words in 512 byte pages. So what I would suggest people do is that you would just add more new code to the flash memory and add, if you want to change it, just redefine them until you are happy with the application. Then you reboot the system, reload the system, then you get a fresh, all the flash memory cleaned up, erased, and then compile only the verified code. So this way you can build application quite smoothly. And after all the code are verified, you erase segment D and copy your new user variables to this segment, and the application should boot up with your application. So this is how you do it. Thank you. Okay, that's as much as the talk is about. Now let me show you some, do some demo. Okay, here is the Code Composer Studio 5.2, and this is what they call an edit perspective. The perspective is a new term, I think. That's a configuration of various panels on the window, and which is optimized for certain tasks at certain stage of your code development. So when you first start, you always get into the edit perspective, and the edit perspective, you have this big editor window where you have your source code, and somehow just copy. I only have one file, which I called 430 eForth _ c.asm. So that's the current version. And so if you can get this this file copied into this project, and in this named this file, and if it is in this project and this project is clicked so it's active, then you can do compilation. Okay, this hammer is the compiler or the builder. Let me see. Let me make a little bit of change here, so I can to let it to treat as a new file, and now it's compiling. Okay, actually assembling. This panel, the console panel, shows you all the progress of the assembly and the linking, and then it shows a whole bunch of error messages. Actually, these are not error messages. These are just warnings. I got 13 warnings and no error. So ignore all the warnings, and as long as you get this this line, finished building target, and you have 430 eForth _ c.out. Okay, this output file is what important. Okay, once you get that the .out file and the assembly is successful, now you can go to the debugger. If I push this debugger button, okay, then it turns into the debugger perspective, and it actually tries to download the code into the LaunchPad. So here, this debugger has lots of buttons that you can push, and these are basically for you to single step through the code, and this is reset And this is the resume button. That's what I'll push to start the code. And here in the editor window, okay, the resume button is pushed, so this one is lit up, and it is running. Okay, there, the board is running. Okay, and the first thing I do is to light up the two LEDs, and it is in a waiting loop in the software UART. So it is waiting for me to push a B key, a B character, so that it can detect the baud rate and then start the UART running. So let me go get to the where is my hyperterminal? I hope that you you have hyperterminal installed here, and now let me just push the B key. Okay, the light goes out, and then eForth started up. Okay, so we have here we have the 430 eForth running, and I think the standard way to the word will just display all the words that's in the system. Okay, so here, let me see. Okay, here I will just do a demo of a few words. So hex and the 200 dump, and this displays the beginning of the RAM memory, and the first 12 words are actually the variables, the system variables in eForth. And so when you are running the eForth, many of the variables will change accordingly. And the C000 dump, that's the beginning of the code page. The code starts from C000 and runs up to FE, I think. And let me see. I can show you the D700 dump, and that's the end. That's at the end of the code. D780. Okay. Now you can see it's the end is at I think D788, and following that it's all unerased. It's all erased flash memory. So I think let me just show do the demo. Test 1 CR code. Hello. Okay, so test 1. I think it's successful. Sorry, the word misspelled it. But let's go look at the D780 dump. You can see the new code is written in the flash memory. So this is the way to the new code is written directly into the flash memory. But when you add new code, well, it is very difficult to forget because you cannot always go back to the 512 byte boundaries. And so I would suggest that you don't erase anything. Just keep on adding new words until you fill the whole memory. And when you don't have any memory to work at, then reload the eForth system. So you debug your code, and then the next time you load first only the verified code, and then from there you can go up doing some more work. Okay, let me show you the segment D, which is at 1000. Actually, segment D only has 64 bytes, okay? And so this is on a very small area. But the segment D you can erase individually. Segment A, B, C, D are only 64 bytes per page. And that you can erase individually and independent of the main memory. And this way, I think I store the system variables in segment D, and this part you can erase, and you can write over, and this way you can do your turnkey system. Let me just show you that to erase this one, I say 1000 erase, and 1000 dump. See, it is erased, the whole page. And so if you want to, you can copy the 200, 1000. I'll copy 20 bytes. This is right. Okay, this way I copy the 20 bytes from the start of the RAM memory into segment D, and if I dump 7, and there I have a new the fresh copy of user variables. And now if I say words, you see test1 is on top. And now, I haven't done it before, but if I reset the board, I should come up with test1. I don't think it worked. No, it's not reset yet. Okay, I cannot reset it. Okay.
Is there a fourth word? Is there a fourth word that will jump to reset factor?
Let's see. Let me just unplug this guy. Plug it back in. Okay. So it starts, and if I push B. Okay. Well, doesn't work.
Why don't you?
Okay, yeah, I think that's a must check I can show you.
Great.
Okay.